Hi, everybody. Hope everybody's still awake. Before we start the panel, we're going to do like a quick poll. Number one, who here believes that integrated NTN, 5G, 6G, we don't care, integrated terrestrial and satellite-based communication is the future of satellite-based communication? Raise your hands. All right, those guys over there who didn't raise your hands, we're going to have a chat later, okay? All right, question number two. How many of you guys believe that Asia Pacific is in a really unique position to lead the transformation to 5G NTN? Raise your hands. All right, well, this one is a little bit less enthusiastic, but I guess we can talk about it some more. So my name is Lisa Kuo. I work at Rocket Lab. At Rocket Lab, we love to solve hard problems. 5G NTN is definitely one of the hard problems that we love solving. And then today, I am joined with three distinguished speakers who also love to solve this problem. So speakers, please introduce yourself. Yes, go ahead.
Hi everyone, good afternoon. I'm Jen-Ming from the Honghai Research Institute. This is the known as Foxconn Technology Group, and Honghai is the mother company of Foxconn, and we are known for we are the global electronic manufacturing service company, one of the largest one. That we have the over 200 campuses worldwide in 25 countries. And we are best known for the manufacturing assembly for the smartphone, iPhone, and consumer electronics, and also the data center, the servers, and also AI servers for NVIDIA. And in recent years, we are diversifying into the more sections like EV, robotics, and space. And in 2023 November, we have launched 2 satellites into the space as experimental pilot run. And the two satellites has been operating in the orbit since them till now. It's been 2 years. We are running the satellite on daily basis for the NTN for communication purpose, and we have collect a lot of data and they build a lot lots of the collect the parameters and photos and experimental data that at the first hand that we are happy about that. And we are entering so we leverage on the mass production capability and the supply chain management. We are entering we are positioning ourselves to entering the space segment in order to have end-to-end control for the space, for the end-to-end space communication from the space to the ground terminals, and hopefully that's where we are. Thank you.
Okay, good afternoon, everyone. I'm Evin Liao, representing the Taiwan Space Agency, TASA. TASA is the Taiwan's national organization responsible for the space technology development and the industry promotion. Our vision is very clear. There are 2 points. First one is enhancing national security. You might know that there are 24 sea cables within 9 terrestrial nodes in this island. So something happened, so you know what will be happened. So neighbor is very important. Okay. The second one is to develop the industry promotion. The mission spans from scientific satellites and small satellite technology and the autonomous launch capability, to supporting Taiwan's mature space, the commercial sector. Okay, so in recent years, the TASA focused on the Liao Earth orbital, like the Earth observation, the remote sensing, the communication payload, the small cell platform, and also the launch capability I just said. So I can share in the whole day that we talk many about the Taiwan supply chain is very strong. So now we can take advantage of this strong capability to the space sector. And then now about the global space economy, I can share you information. In 2024, in the SIA report, the global space industry is $415 billion US. And at the same time, the Taiwan's space industry is nearly $9 billion US. So it's about 2%. However, in the past 4 years, the global growth rate of the space revenue is about 2 to 3%. And at the same period, Taiwan's growth rate is 10 to 11%. So Taiwan in Asia Pacific have a very strong growth power. Okay, so the TASA is focused on this satellite platform, and we are very happy to exploring the new opportunity with all of you, and connect the space and the 5G and to the smarter and the more resilient world. Thank you.
Hello, everyone. I'm I-Kang from MediaTek. Our organization is functioning as advanced communication technology responsible for every new generation mobile cellular technology. So we have been working from 3G to 4G, 4G to 5G, now 5G to 6G. So that is our job. So our R&R is everything from the research, standardization. We do the prototype to prove the engineering feasibility, and also helping our company to do the like a business planning. And regarding to the MediaTek, we are, in terms of volume, we are the biggest smartphone chipset provider around the world. And of course, we do everything on the ground. And yeah, the company portfolio is quite broad, and also recently we are also trying to enter some AI business. And in particular, in addition to our regular job, in particular, I'm also leading the MediaTek internal NTN R&D program. So I also mentioned later, I think in past few years, we have a journey with many of the NTN society partners. So we started this IoT NTN with IMASE by 2020, and then also moved to the like Utah Say OneWeb from 24, 25, and yeah, so it's still ongoing. Yeah, thank you.
All right, thank you, panelists, for your self-introduction. So we're going to ask you the first question. Please, everybody answer this question. The same question I just asked the audience. APAC has traditionally been a leader in terrestrial 5G NTN related equipment, network, et cetera, et cetera. So do we believe that we can leverage our strength in the 5G, on the terrestrial and bring it into space? Do we believe that? And if that's the case, how would you, representing your company or organization, how would you go about doing that?
Yeah, I think Asia Pacific has the advantage in the technology, driving the scalability in manufacturing for the cost, and also the deployment of the scenarios, and also the market itself. So the strong 5G ecosystems and NTN ecosystem and early engagement, early commercialization and engagement that would the Asia Pacific has track records for the early demo, for early commercialized for every generation of the cellular generations. So and also the advanced supply chain, vertical integration capability, and the also end-to-end manufacturing and integration. That is what the strengths of the Asia Pacific. For example, into the NTN and satellite communication, like that the Asia Pacific, it would be could be in satellite platform, and also the ground especially the ground segment and like the UT and the gateway. Also, especially the components like RF antenna and the semiconductor supply chain. These are all the strengths of the Asia Pacific could contribute. It is able to the region to move the segment to the more affordable mass production, scalability, NTN, and these are all critical for the scale and to be viable for the IoT and mobility and consumer NTN solutions. Yeah.
Okay, thank you. In my opinion, Asia Pacific has been a truly leader in 5G. Okay, thanks to the high density population, and you might know that there are 8.2 billion people in the global population, and there are nearly 60% of the people in Asia Pacific. So the first one is the high density population. The second one is the very strong mobile operator. And the third is the world-class the semiconductor and the device industry. So as we move into the 5G NTN, we can take advantage of this chance. So we already have the deep experiences in system integration, satellite technologies, and the terminal innovation. And now we can connect the space and the ground station technologies into the 5G NTN with the 5G and the future 6G network. So we can get together to make it more seamlessly than ever before. And what also makes Asia Pacific unique is the diversity of our ecosystem. As we know, Japan and Korea is the leader in advanced 5G infrastructure. And Taiwan has the strong supply chain. We have the good satellite component and the system integration capability, and also some experiences. And also the Southeast Asia brings the fast-growing markets and the new use cases. So the diversity drives the faster innovation and the collaboration across the region. So in Taiwan, from Taiwan's perspective, the TASA, we are eager and we are very aggressive in recent years, especially to co-work with the inside and outside partners. So we have some small cell platform. Maybe I can talk more about it later. Yeah, thank you.
Yeah, thank you. Just a quick response. In terms of market size, Asia Pacific is actually quite fragmented. I think now US, China, and Europe are all building their own constellation, and there are a lot of coverage problems. So by nature, the market there has been there for a long time. So it is not surprised like a driving force and deployment was starting from that region. But indeed, if you go back to look at from supply chain perspective, indeed, Asia Pacific have many like a vendor. Like a Foxconn, like MediaTek. So we have been supplying the mobile ecosystem for a long time. So the real game changer is that now NTN is crossing the mobile technology for the satellite communication, so that the satellite ecosystem can take advantage and leverage from the mobile ecosystem. And that is where the strength comes from. So indeed, there could be a good opportunity, but there is also a problem that how those like a medium and small vendor, especially in Asia Pacific, how they can really understand the requirement and also get entered like into certificate by all those mega constellation. Certainly there could be challenging, but indeed the supply chain here could be quite flexible and very capable and also reliable. So that could be a very good value proposition. And of course, there are many national programs. I can also see in the Asia Pacific, like many countries are trying to work together. So indeed, I think there could be quite a unique role that Asia Pacific can play, but certainly there's also a challenge.
Thank you for your thoughtful answers. And this question is for Foxconn and MediaTek. Since you guys were part of the big contributors on the terrestrial 5G, leading in APAC, could you tell us about what you think is like a technological challenge for integrating 5G with terrestrial as well as the satellite network? And just to be fair for I-Kang, we're going to start that way.
Already?
Yes.
I have no problem to start. It's okay. Yeah, I think it has been a journey that we're trying to investigate where is a gap to apply the mobile technology to the satellite. I think, very frankly speaking, before I think this August 2020, when we successed the first connection with the Inmarsat geo satellite. Before that, nobody believed that. Even we have a project in CGP, we said NB-IoT, we can modify the protocol to make it success over the Liao and geo, but nobody believed the connection can success. But of course, thanks to all the experiment, and also we do find a problem, and certainly we also contribute a lot to the standard to fix the standard and make sure that works. And now we have an interoperable solution. Now from IoT NTN, then we have an NR-NTN to both to the S-band, L-band. And of course, from now on, my team, we are working on the KU band. We just have a press this morning. So we do see from the a smartphone part, there's no doubt it works. We have been demonstrating Mobile Congress for a couple of years. And direct to sell and also the IoT NTN in the US market is happening. So there's no doubt. And of course, from engineering-wise, from productization, commoditized-wise, there are still a lot of things we need to also communicate with the consumer, because there could be a wrong perception by consumer. They believe they can still watch the YouTube when connecting to satellite. So there's a lot of market education and communication work that still is pending. Certainly, yeah, we need to keep work together on that. But moving forward, what we're trying to do is move into the KU, because the KU, of course, KA is also similar. That is a mainstream satellite spectrum. There is a sufficient capacity. And of course, we assume if a smartphone getting popular, it will quickly exhaust all the capacity in the sky. So in the FR1, the available spectrum is actually quite limited. Of course, what we're trying to do is fill the gap to hopefully also make the NR-NTN also be capable to support the mainstream satellite spectrum. That is why we have been driving that for 2 years, and we are working with Inmarsat closely with that. And of course, on the forward, there is a 6G NTN, but I think I should leave the time to Professor Wu. Yeah, I can talk about that later.
Okay, there are, of course, several major technical challenges. Okay, first is related to latency. The LEO latency is shorter than the GEO-MEO, but is much longer than the terrestrial network. From 5 kilometers to 500 kilometers is a lot difference. The latency, the propagation delay, and also the jitter variation, the jitter in delay, that make the non-terrestrial network much different with the terrestrial network. For example, that it's difficult to manage the round trip time of the satellite to the ground is much longer than the ground GNOB, the base station, to the devices. So it's it's difficult to have the HRRQ and for this kind of round trip time delay, and also there's fast delay variations because of the motion of the satellite, and when the satellite moving in the LEO orbit, the delay jitter changes that makes challenges for the HRRQ and round trip time delay, such as things. So it impacts on the HRRQ timing, the control loops, and also the interactive applications for the mobile procedures. Like, it's not like what we used to have in the terrestrial. And also another critical challenge related to the latency is for the timing and synchronizations, for the timing advance, for the delay, for example, we have to have a network, we need to have multiple devices, users to have multiple access to the space. But every device has different delays. So it makes it difficult for the waveform to have precise synchronizations. That the issues need to be resolved. Although there are different techniques for the delay profile for different users, for different satellite at different elevation angles, different orbit positions. But that makes the lots of challenges in having synchronization requirement waveforms. So latency is one thing. The second thing is about the spectrum sharing that I-Kang has mentioned, that the spectrum sharing for the KU band, or even for the S band, L band, especially for the D2D, D2 cell applications, for spectrum sharing among different constellations. Either they are open constellations, need to interoperate to each other. They have interference issues among the different constellations. Also, the constellation between the NTN and the NTN, the non-terrestrial and the terrestrial network, the spectrum management between the network and also the uplink and downlink. So there are lots of these spectrum interference and management issues as well. And the third technical change will be related to the components. For example, that if we consider the D2C to the cell, D2D is the future, that would be there will be trade-off between there's form factor issues that to have enough link budget, have EIRP that's sufficient to provide enough speed of the data stream, that it need to trade off the ground receiving powers and the space EIRP as well. There lots of the component form factor raised issue that need to be taken care of.
So I'm going to ask the same question, but for a different topic. Evin, if you don't mind telling us, what do you think the policy and the regulatory challenges of incorporating 5G NTN in the Asia-Pacific region?
Okay, thank you. I think the biggest challenge in 5G NTN mainly is about the regulation and the coordination. Okay, well, the first one is the spectrum. Every country manages the frequency differently. So the harmonizing the satellites and the telecom bands are still complex. So it's a barrier layer. So we need more time to discuss or negotiate. Okay, and the second one is about the licensing. Okay, so most of the regulator, they separate the satellite and the telecom rules. So which will slow down the hybrid 5G services. Okay, it's a barrier there also. And the third is that we need more stronger standards and interoperability, the test-bed plans. So about the test beds, I will share one example from TASA. Maybe you maybe heard about SMIP. It's a program from TASA. We designed this program. SMIP means the small satellite manufactured industrial platform. Okay, the program is very special. The future is between the traditional contract to the R&D program with government subsidy. So if you are the R&D program, you need to spend more time, and the government or our national missions will not be satisfied. And also, if you use the traditional contract, and even you are the very large company, if you do not have the experiences about manufacturing the satellite, you will not have the chance to manufacture to TASA. So we designed this special program as MIP, the compromised. And we hand in hand, we teach the two companies So I echo my talking is about the B5G, the communication, the constellation. We have 6 satellites inside, and the first 2 we will manufacture by ourselves. So we leverage the 4 satellites, communication satellites, to the SMIP. So there are 2 companies in the near future, the 2 for each companies. And we hand in hand to teach them from the system integration to the ground technologies. And also we teach them how to operate and manage the satellites. So I think regulation, coordination, and innovation is very important. Innovation is not only about technology, and it could be put into anything in the space domain. Thank you.
Thank you so much. I just wanted to clarify that I thought we had 15 more minutes because this session is supposed to go until 5:10, right? Just want to clarify that. All right, so you guys are in luck because we're gonna do a fun round. It's called the lightning round. So please pass 3. Everybody gets 3. And then also please pass a pen. Everybody gets 1 pen. Okay, this is going to be a lightning round. So, I will ask a question. I will give you multiple choices. You are going to write down your answer. Don't show the audience yet. After I count to 1, 2, 3, you're going to flip your answers and show the audience what your answer is, okay? Number 1 question. Where would you, whether it's organization, yourself, I don't care, where would you prioritize your investment in 5G NTN? Here's your multiple choice. Technology, manufacturing, regulation, partnership. Or if you have other answers, you can do that too. Write as big as you can because the audience needs to see your answer. No, just 1. Pick 1. Just pick 1. All right, we're gonna give Jen-Ming a little bit of time. All right, count to 3. 1, 2, 3. Show the audience. All right, Foxconn said manufacturing, TASA said partnership, and then MediaTek said 4. I have no idea what that is. Partnership. So, okay, 2 people for partnership, 1 person for manufacturing, although it's not surprising that Foxconn said manufacturing. But please, Foxconn, tell us, why did you choose manufacturing as your investment?
Okay, everything is about cost. The way to make make this NTN to be economically viable is to be scalable, to be manufacturing, to make the manufacturing scalable to drive down the cost, so that to have a healthy of the economics, so manufacturing is the way to drive down cost and enhance the economical health.
Thank you so much. We're going to move on to question number 2. So get your second piece of paper ready. So we all know that the Western countries and Western players, like the big Constellation that I shall not name, is definitely leading the game in trying to do 5G NTN. So the question, should APAC aim to collaborate or compete with the Western players? Collaborate or compete? Of course, you can do hybrid or send any other answers that you want to do. All right, 1, 2, 3. Hybrid, collaborate, and both. So basically, the Foxconn and MediaTek said we should do both. And then, but TASA, please tell us, just collaborate, no compete?
Okay, my reason is very simple. I would like to take advantage of this event, and because I saw the many friends that comes from the many countries. So I would like to make more friends and make more collaboration and partnership. So I think the collaboration is much more important than everything now. Thank you.
All right, we're gonna do the last question. So, last question. What is the biggest challenge in APAC to achieving leadership or partnership in 5G NTN. Biggest challenge. The selection could be regulation, funding, technology, collaboration, geopolitics, anything. Single biggest challenge that comes to your mind. One, two, three. We have some interesting answers here. Collaboration, regulation, time. Please explain. Time.
Thank you. My turn. Yeah, I think as you can see, the market is moving fast. But we have been in this journey for a couple of years. And we know how drastically that a new vendor, like a legacy vendor, even in the satellite operator, there is a newcomer, and there is also the, you can say the incumbent. And we are from the mobile industry, and my colleague make a joke is that when we work with some of our partners, I cannot mention the name, but we found that our baseband clock is very different. like in the smartphone, we need to have a product every year, every 6 months, every 12 months. And sometimes we found that we're talking at a very different frequency when we're talking to different partners. And so we realized that could be the opportunity. It can also be the risk, but it depends on how you read it. But of course, from MediaTek side, we do hope our contribution to the satellite ecosystem is that we can try to somehow accelerate, helping them to launch what they want in a faster manner. So the time to market to us is very fast, and yeah, many friends, many partners approach us. They say, okay, can you do this with us? Can you do that with us? And then when we discuss, we say, okay, don't worry about us. When you are ready, we already done everything. So we do see that the time to market is actually very, very important.
So let me ask a following question. How much time do you need?
I saw that you have a question later. I can answer that together.
No. Do I have time for one of the Slido questions? Yes, okay, yes. So we're going to do the one Slido question that is specifically for TASA. For TASA, can you describe the status and purpose of the Beyond 5G LEO program?
Okay, let me explain some status of this program. This program spent 5 years and divided two phases. The phase one, we will use 1 year to do the design situation. So every 1 year, we will have some record about the two companies. And the second one is the 3 years plus 1 year for the launch. And now the status is we have selected the two companies, Compo and Wistron. Okay, it's announced already. So now we are discussing very closely even every day. And also because each company need to design, manufacture, and launch and operate the two satellites. So lots of things to do, and they and of course TASA ourselves, we need more partnership in the worldwide. So welcome everyone to come to find us. Also find Compo or Wistron. You might have lots of opportunity to go through that. Thank you.
Thank you so much. Thank you so much for the panelists, and thank you guys so much for joining on this panel.
Thank you, Lisa, and thank you for the panelists.